This first tip is on a butt joint, but it could apply to most any type of joint where you have a tack on the very end. If you start the weld right on the tack and you melt that tack at all, and there's any stress at all on the joint, a lot of times it'll pull apart. You'll lose your fit up. So putting a tack a 1/2 inch inboard and then jumping right back to the tack can usually prevent that. And if you make the tack nice and small, you can usually blend it in where you can't even tell you went over it. This is fairly thin material, 050, and with a thin aluminum butt joint, you can't take really big steps and have big wide ripples. Otherwise you'll keyhole out. So you take nice small steps and you get the wire in there often. I'm just taking nice small steps, about moving only about a 1/16 of an inch at a time. I'm using a tapered electrode and I've got it pointed upward just a little bit to help push the argon gas up and keep my cleaning action path even. This is a number 5 clear cup that I'm using. I'm probably at around 15 to 20 CFH pure argon. Since flow meters can vary, you want to pay attention to that cleaning path just right outside the bead and make sure you've got a little bit. If you don't have enough argon, you probably won't have any of that frosty looking area right outside the bead. A good rule of thumb for argon flow is 2 to 3 times the cup size as far as your CFH on your flow meter. Alright, here are the settings and the details. You can freeze frame if you want to copy any of this down, but we'll move on to the next joint. Corner joints tend to need just a little bit less heat than inside fillet welds, like laps and tees. I put the camera on the machine while I was welding this. I used the foot pedal, but it seemed to be averaging about 38 amps for the most part. I used 200 hertz on the AC frequency and a fairly slow travel speed, again not stepping out too far, and you can see I'm backing up actually just a little bit each time I feed rod, and that can help you from opening up a keyhole if you've got any kind of little gaps or anything, if you don't have a perfect fit. The travel speed going on here is about 1/8 of an inch per second, and that also means I'm traveling 1 inch every 8 seconds, and that is just a starting point. Like if you were doing a whole bunch of these things and you had really good fit ups, you'd probably pick up your travel speed. But when you are learning, you want to go slower, concentrate on doing other things right, and then the speed will come later. No point in getting in a hurry. Higher frequencies can help with thin aluminum, especially on lap joints, in really pinpointing the arc, but it doesn't make as much difference as a lot of people think. I set this one all the way up to 400 hertz, and I turn the sound off here because it sounds like a mosquito in your ear. And this is something you probably won't want to listen to all day, but it can help you make a smaller bead when that's what's necessary. And here are the settings I used for that lap joint. Most of the time you won't need pulse settings for aluminum, but I decided to play around with some pulse settings to get full penetration on this aluminum tube while not getting it saturated with heat. Okay, I'm going to go through this really quickly because there's quite a few settings when you're doing pulse. AC frequency 222 hertz. AC balance 32% cleaning. 1 full second of pre-flow. Post-flow around 7 seconds. 2 pulses per second. Base current at 45%. And pulse width 50%. These settings won't allow the puddle to cool much, but it will back it off to keep heat from just continually building up. And that braided copper wire is sucking up a lot of heat too. So I'm trying to dab filler every single pulse. It's kind of hard to keep up with, but it's maintaining. It's not getting out of hand, and that's the goal on something like this where you're welding out near an end where heat can just saturate and the puddle start running like water, and you don't want that. So this is just a tip for a one-off. Might even be better to shove a big ball of aluminum foil in the end, but I didn't have any on this particular day. I did have the copper wire. TIG welding requires a steady hand, and you don't always have a place to prop that's convenient. But if you've got a TIG finger in your pocket, you've got a prop in your pocket. You can prop right next to the weld, right on the hot metal. You can hang in there for a really long time without ever even feeling any heat. That lets you focus on making a good weld instead of how bad your fingers are burning. Maybe you can relate to this. I know I can. I've hung in there too long when things are going well, trying to finish a weld and not make an extra tie-in to make the weld looking good, and I wind up with a bad burn on my knuckle or whatever finger I'm propping on just because I didn't want to stop. I don't wear a TIG finger for every single job I do, but it gives me a lot of options. Some welds get really hot really quick, like aluminum. If you know, you know. Whether you're up overhead, out of position, or on the bench, it's going to help you hold a steady hand, especially on small bore pipe. I walk the cup when I can, but there's times when you can't. There's stuff in the way. With a TIG finger in your pocket, you can freehand and still be steady, even on preheated pipe. Imagine trying to prop on a 5F aluminum test like this without a TIG finger, just with your bare glove. After half an inch, it would be so hot you wouldn't be able to do it. With a TIG finger, you can make the whole run, not ever get hot. If you've got a 6G pipe test in your future, you'd like to have a TIG finger in your pocket. There are certain root pass techniques that work better without any side-to-side motion, and that happens easier with a TIG finger than it does walking the cup. Just another option. On long runs of aluminum, you can drag that TIG finger right next to the weld. Your fingers will never get hot, and you can be steady and smooth. TIG finger comes in a regular size as well as an XL size for people with big fingers, or you can slip 2 fingers in it for added protection on those really hot jobs. Made in the USA by friends and family, made from material made in the USA.